Next, scalar product of two vectors. Scalar products. The formula says A vector dot B vector. So it is otherwise known as dot product. It is otherwise known as dot product. A vector dot B vector is equal to AB cos theta. Here the resultant is a scalar. Resultant AB cos theta is a scalar. Vector A, vector B. Resultant will be along this direction. R is equal to D into component of A along this direction. Component of A along this direction is A cos theta, that is nothing but A dot B. So, what is the example, sir? Scalar product, what is the example? Work done. Formula F vector dot S vector, that is Fs cos theta. Work done is a scalar. Force and displacement are vectors. So resultant Fs cos theta, this is called work done, that is a scalar quantity. It does not depend on direction. Whereas force and displacement, both are vector quantities. Now we are going to see the properties of the vectors. Scalar product. A dot B is equal to B dot A. A dot B means AB cos theta. B dot A means BA cos of minus theta. BA cos of minus theta. Cos of minus theta is cos theta only. So I can write A dot B is equal to B dot A. A dot B is also AB cos theta. This is also AB. B or AB product is same. So I can write B dot A. Commutative. Next step. Distributive law. A dot B plus C is equal to A dot B plus A dot C. This is called distributive law. Distributive law for scalar product of three vectors here. A, B, C, three vectors here. Simple concept now. Everything we can prove. Sir, when it will be maximum? When it will be minimum? Maximum value of R means theta is equal to 0. When theta is equal to 0, R is equal to AB cos 0. That is 1. So you will get AB. Cos 0 is 1. Minimum value. When theta is equal to, here everybody will write wrongly. It is 180. R is equal to minus AB. Negative value is less than 0, man. Zero. When theta is equal to 90 degree, R is equal. Resultant is 0. Cos 90 is 0. So these two vectors are perpendicular. This is the case. Theta is equal to 0 means A dot A is A square. A dot A is called A square. That means self dot product. Self dot product means A dot A is equal to AA cos 0. Cos 0 is 1. So I will get A square. This is called self dot product. Unit vector. Unit vector means the thing represents some direction arrow. This is called the cap. Magnitude is unity, but it has got some direction. That is called unit vector. Unit vector means unit magnitude, but it is a vector, so direction. What is the value? Unit vector. N vector dot N vector. N vector dot N vector. That is unit vector. Both are unity. A dot B cos theta. Unit vector. A magnitude is 1. B magnitude is 1. Theta is 0. Answer is 1. A vector. A cap dot A cap. That is 1 into 1 cos 0. Unity. Sir, I want to write the vector A in terms of 3-coordinate system. Right? IJK. What is IJK? You are representing the vector along x-axis I cap, along y-axis j cap, along z-axis k cap. I dot I, j dot j, k dot k. Sir, n dot n 1. So same concept, 1. Because theta 0. Sir, I want I dot j, j dot k, k dot I. I dot j means I and j are perpendicular here. J and k are perpendicular. K and I are perpendicular. So all the answer is 0. Cos 90, A dot B, cos 90, cos 90 is 0. So this is basic information. Now I want to represent A dot B. Keep this in mind and write A vector is equal to AXI plus AYJ plus AZK. B vector is equal to BXI plus BYJ plus BZK. Now, A vector dot B vector I want to calculate. A vector dot B vector. A dot B. AXI plus AYJ plus AZK dot BXI BYJ BZK. AX I dot AX BX I dot I next plus AXI BYJ AXI BZK, these terms will become 0 because I dot J 0, I dot K 0. Similarly, AY into J BXI, J versus I 0. Next AY dot BY J dot J AZ dot BZ K dot K I dot I 1 J dot J 1 K dot K 1 remaining product I dot J J dot K dot I reverse everything 0. So AX dot BX plus AY dot BY plus AZ dot BZ. This is the result. So these are the properties of scalar product of two vectors. Scalar product of two vectors. Now we are going to see vector product and its properties. Vector product of two vectors. Very important point here is A vector cross B vector. So this is otherwise known as cross product. Cross product. A vector cross B vector is equal to modulus of A modulus of B sin theta n cap. Resultant is a vector. Resultant is a vector quantity. In the case of scalar product or dot product, resultant is a scalar. Here resultant is a vector. Example, A vector cross B vector. Resultant is a vector. That is torque. Torque tau. R cross F. R cross F. Displacement and force, both are vectors. Resultant torque, that is also a vector. Next question, if the resultant is a vector, what is the direction of resultant? You have displacement vector, you have force vector, what is the direction of torque? The direction of resultant will be in the plane perpendicular to both the vectors. R and F you are taking over. That R and F, which plane you are taking? Perpendicular to that plane will be the resultant torque. For that we are following two rules. One rule is right hand corkscrew rule. Another we are following thumb rule to calculate the resultant. Sir, I have vector A I have vector B making an angle theta. You are calculating B cross. No, sir. This is A vector. This is B vector. I want to calculate A cross B. Whether you do A cross B or whether you do B cross A, the concept is clockwise or anti-clockwise. You see here, this is clockwise. This is anti-clockwise. Clockwise, when you say, you see here, curling of finger direction is clockwise. You see the thumb direction, downward. So clockwise means the resultant is downwards. Anti-clockwise. See, this is anti-clockwise. Curling of finger. See the thumb. Upwards. Anti-clockwise means upwards. Clockwise means downwards. Resultant. This is clockwise. Resultant R. That is N cap. Resultant R. That is N cap. So this is called vector product of two vectors. What are the properties? Properties. Sir, A cross B is not equal to B cross A. It is not commutative. Why it is not commutative, sir? A cross B is AB sin theta. B cross A is BA sin of minus theta. Sin of minus theta is minus sin theta. So minus A cross B is equal to minus B cross A. Anti-commutative. It's not commutative, it is anti-commutative. Correct? Second. Sir, when it will be maximum, when it will be minimum, when theta is equal to 0, when theta is equal to 180, when theta is equal to 90. When theta is equal to 0, resultant R will be 0 because sin 0 is 0. Sin 180 resultant is 0 because sin 0 is 0, sin 180 is also 0. Maximum value R max root of A square plus B square plus 2AB. It is not like that. Theta is equal to 90. Resultant theta is equal to 0 means R is equal to 0 and theta is equal to 180 also R is equal to 0. Maximum case, resultant is maximum. Sin 90 is 1 modulus of A modulus of sin 90 is 1. Correct, Amma? Fine. Next step. Theta is equal to 0 means both the vectors are parallel, anti-parallel, perpendicular. Parallel, anti-parallel. Parallel case, anti-parallel case, the resultant is 0. When both the vectors are perpendicular, the resultant will be maximum AB. Now, similar to scalar product, we have to discuss I cross I, J cross J, K cross K. Sir, self vector product AA sin 0. Self vector product means A and A same direction. Sin 0. Sin 0 is 0. Resultant is 0. Along the direction I dot I 0. Because sin 0 0. J dot J 0. K dot J 0. No, sir. I want I cross J perpendicular. J cross K perpendicular. K cross I perpendicular. I J K. This is the order. I cross J resultant is K. J cross K resultant is I. K cross I resultant is J. Simple. Sir, I want I cross K. I cross K. K cross J. J cross I. I cross K. Generally, all the three should come. I and K has come. So resultant is J. But you are skipped after I. You have skipped J. Then only you have written K. Since skipping is there, means K J. After K, I only should come. You have written J. So minus I. J after K only should come. You have written I minus. Sir, I want to write A cross B. Like scalar product of two vectors, I want to write A cross B. How will you write? A is equal to AXI plus AYJ plus AZK. B vector BXI plus BYJ plus BZK. A cross B, I want to calculate. Determinant, max teacher will tell I, J, K. AX, AY, AZ. BX, BY. Now, resultant is equal to, when you are writing I, leave this column and this row, cross multiply this product. What product? I into this column, this row you leave it. AY BZ minus BY AZ. Plus J cap, leave this column, this row. AZ BX minus AX. Sir, like this only I will put, sir. First I will put AX BZ, sir. Then you can put minus. AX BZ minus BX AZ. In that case, you have to put a negative sign. Plus K. Leave this column. and leave this row. Ax dy minus bx ay. This is A cross B. Problems they will ask based on this concept. Correct, Amma? So these are the properties of vector product of two vectors. So we have seen scalar product and the vector product, the properties of scalar product of two vectors and vector product of two vectors we have seen. And the most important, resolution of vector also we have discussed. Okay, Amma? Second part we are going to talk about projectile motion. Kinematics second part, projectile motion we are going to talk. Thank you.